1 mole of sodium plus 1 mole of calcium gives me 3 equivalents of charge. Because sodium only provides 1 equivalent, but calcium provides 2 equivalents. So 1 plus 2 is 3. So if I only had chloride to balance that, I'd have to have 3 equivalents of chloride. Okay? And for chloride, it would be 3 moles. If I had sulfate, I'd only have to have 1.5 moles. Because it's 2, right? 3 divided by 2. All right, so, ooh, this is an ugly calculation. Look at all that dimensional analysis up there. Let's talk about it. It says a lab does a test indicating a blood calcium of 8 milliequivalents per liter. How many moles of calcium iron are point? Now look at this unit right here. I know you guys, when you see it written like this, it means 8.8 milliequivalents in 1 liter. See how it's written like this, divided? That's what it means, right?
Yes.
So when you see this, what do you think? What you should be thinking is, hey, that's a conversion. I'm not going to start there because it's a conversion. But what if I start right here? And I multiply this by that, I get rid of liters. See right here? And I'm left with milliequivalents. And then they convert milliequivalents into equivalents using 1,000 to 1. And then they say, okay, for calcium, there's 2 equivalents for 1 mole. Why are there 2 equivalents for 1 mole for calcium? Because the charge is 2 plus. So there's 2 equivalents for every 1 mole of calcium. Therefore, if you had 8.8 milliequivalents per liter of calcium, you would have 0.0022 moles of calcium. This unit is used very often in this type of test. So whether you're going to be a nurse or a vet tech, you'll see these units often. Now in that section that I teach at 1 o'clock, it has a whole bunch of students who are already in the vet tech program, so they know all the instructors are there, right? I know all the instructors in the vet tech program really well. Probably my best friend on campus is Dr. Brown. She's the chair of the vet tech program. So when I go have blood drawn and they send it off to the lab and they send me my results back, I take the printout and I take it over to Dr. Brown. And she looks at all these numbers and she goes, oh, this is a little bit high, this is a little bit low, whatever. But the readout is in milliequivalents like this. That's how they measure, okay? So when you see that unit, don't be freaked out. It means how much charge is coming from this particular ion, okay? Does that make sense? You should be able to do all these units. We're not going to do a whole bunch of these calculations, okay? I'm not going to spend a lot of time on this. Anybody happy about that? Okay. All right. So, your blood plasma contains some positive ions and some negative ions. What are these ions important for in your body? Do I know? What does your body use ions for? How about sending nerve impulses? How about muscle contractions? What happens if you're low on potassium? Anybody know what happens if you're low on potassium? Muscle cramps. Eat a banana. Or
For too high in potassium, you have kidney.
yeah, you can have kidney problems. Or it can precipitate out as stones, right, if you're too high on certain elements. Okay? Particularly calcium or magnesium, right? Where else are they? They're important for muscle contraction, which means beating of the heart, right? If your potassium level is off, you'll often have heart problems. Your heart won't beat right. Because it's just a big muscle, right? Okay? So that's why it's important that you take in the right amount of electrolytes. Now look at the anions down there. Chloride, bicarbonate, that's called biphosphate, and proteins provide all the negative ions. Bicarbonate, important in regulating, once again, what? Blood pH, and we'll talk about pH in the next chapter, also important in regulating muscle contractions, okay? Magnesium, if you give enough magnesium, you can actually relax, this is a muscle relaxer. Magnesium sulfate is used as to stop contractions in women that are in early term labor, right? So if you go into labor and you're only like 24 weeks, they'll give you magnesium sulfate to stop contractions. We talked about that before. Because you need all of these things, when you sweat, you lose a lot of them. That's why you drink solutions that have these things in them, or you eat bananas to provide with the potassium that you're losing, right? Or you just eat a balanced meal, and it should give you enough of everything that you need.
So I have an interesting question.
Yes.
If someone doesn't sweat, where does all these nutrients go? Are they excreted otherwise?
Hopefully your kidneys and your liver are working well to remove the extras that you're taking in. Yeah. There supposedly are weird people or strange. There's a strange condition of people that do not sweat. I can't imagine living that way. I mean, living in the South, oof, because that's your body's mechanism to cool. So if you don't sweat, you have to be ultra careful about getting overheated. It'd be very difficult to live in the South, I would think. You'd have to stay inside all the time.
No, you don't need to
Just
stay
do everything in
inside.
moderation.
Your kidneys work overtime. That's how it
But
works.
regulating body temperature becomes a big issue,
Yeah.
right? When you go running and you exercise, why are you sweating? Because your body is burning sugar. It is literally burning itself, creating heat inside of you. In order to cool you off, you sweat, right? So if you're not sweating, it's very difficult to thermoregulate, control your body temperature, particularly in the summertime. Okay? That's even like if you go outside in the wintertime and you're working, you got a coat on and stuff, that's why you sweat. You go outside and take your coat off and your t-shirt or whatever is damp because you've been sweating. You know it's cold outside. Your body is burning sugar. It is making heat. You have to sweat. It's not very common that there are people that do not sweat, but it's not very common. I sweat like nobody's business. Do what?
Is it hereditary?
I got no idea.
It's called ichthyosis. It's hereditary. I
Yeah.
know 2 people who have it and they're in the same thing.
Yeah, it would make sense. It's got to be a genetic defect somehow. Because it's certainly not, if we lived, back in the caveman days, those people probably wouldn't last very long. Because they don't thermoregulate. If you're chasing a gazelle to try to catch him to eat, your body's going to overheat, you're going to die. It's called natural selection. We've overridden natural selection these days for humans. Right? We get all kinds of people living with all kinds of weird defects and stuff. It's true. Like me with my bad knees, I'd be dead by now. Can't run. Can't chase anything down to catch it to eat it. Eat good. Okay. In 1 mole of iron, how many equivalents are there? Iron 3. That's iron 3 plus. How many equivalents are there?
3.
There's 3 equivalents, right, for 1 mole. Because the charge is 3 plus. What if you had 2.5 moles of sulfate? How many equivalents do you think there are there? Why 5? There's 2 charges, 2 minus, times 2.5. Gives you 5. Okay? An IV bottle contains sodium chloride and only sodium chloride. If sodium is 34 milliequivalents per liter, the chloride concentration is 34 milliequivalents per liter. They have to be the same, if that's all that's in there. Okay?
What was the second one?
5. 2.5 times 2 is 5, right? Gout. Gout is a disease that is common in some people that reach a certain age, normally people over 40, but it can occur in younger people too. It comes from uric acid. Uric acid will precipitate out and form crystals, and it's very painful, okay? And it has to do with the solubility of uric acid. How much can dissolve in your system? If you have too much of it, it forms a solid, and that can be painful. So, solubility is the maximum amount of a solute that can dissolve in a given solvent. The maximum amount that can dissolve is normally given in terms of grams per 100 grams of solvent. In most of our cases, our solvent is water, so it'll be grams of solute per 100 grams of water. Okay? It is temperature sensitive. The higher the temperature, the more you can dissolve. So the solubility changes with temperature. Okay? And we'll show a graph in a minute. Unsaturated solutions have less than the maximum amount. So if you have a cup of water and you just add a couple sprinkles of salt to it, it's still not saturated. It is unsaturated. You could still dissolve some more, right? Okay? That's unsaturated. You could dissolve more before you start to see solid in there. Now, once it is saturated, it contains the maximum amount of solute that can be dissolved. It doesn't mean nothing is happening. What it means is that if you have some solid at the bottom, for every one that dissolves, one more recrystallizes or precipitates and makes a solid. So some is going from being a solid into being dissolved, some other is coming back out and making a solid. This solution is saturated. If I add some more salt, I guess this is, it won't dissolve. It'll just settle down to the bottom. Just like when you get that cold iced tea and you add more sugar to it, it doesn't dissolve, does it? Because it is saturated. Okay? Now, salt disappears when put in water. Does that mean the solution is saturated or unsaturated?
Unsaturated.
It's unsaturated. If it was saturated, it wouldn't dissolve. It would just settle down to the bottom. Sugar added to a cup of water does not disappear. That means it is
Saturated.
saturated. It stays there. You can see it. It's not dissolving. The solution is saturated. It has the maximal amount that it can dissolve. Now here are 3 examples of using numbers to decide is this solution saturated or not. It gives you the maximal amount that you can dissolve at 40 degrees Celsius. At 40 degrees Celsius, you can dissolve 80 grams per 100 grams of water. So you have to compare each of these numbers to that number. A is the easiest one, right? 60 grams of potassium bromide and 100 grams of water. Is that saturated or unsaturated? It's unsaturated because 60 is less than 80, isn't it? Okay. What about B? Saturated. Because even though it's in terms of 200 grams of water, if you divide it in half, it's still more, isn't it? You would have 100 grams of potassium bromide for every 100 grams of water. And C? What about C? Unsaturated. If I put that in terms of 100 grams of water, how much potassium bromide would I have? I would have 50, wouldn't I? And 50 is less than 80, so it is unsaturated. Okay? Now, on this graph, you can see that solubility depends on temperature. Look, here's our friend sugar. This is glucose right here. At 0 degrees Celsius, glucose barely dissolves in water. As I increase the temperature, look at this line right here. I'm going to draw it red. If this is about 50 down here, at 40 degrees C, I can dissolve like 130 grams of glucose. Wow. Okay? So the way to use this chart is how much sodium nitrate will dissolve at 60 degrees Celsius? What is the solubility of sodium nitrate at 60 degrees Celsius? Anybody? Roughly 120 grams per 100 grams of water. You see how I got that? Just looking at the axis, right? So there'll be a couple homework problems like that. Now, one of the big things that happens is gases are different. Gases actually decrease in solubility as temperature increases. Okay? They're odd. So as temperatures increase, gases solubility goes down, which is opposite to everything else. Okay? Most ionic compounds increase solubility, but gases decrease solubility. So, why would a bottle of carbonated drink possibly explode in the sun? Why? Well, all that carbonation that they have in there degasses, right? If you have it sealed up, what happens? It's going to swell up, right? Okay. Same thing. Why do fish die in warm weather? What do fish need in the water? They need oxygen, don't they? So when it gets hot outside, what happens? Oxygen doesn't dissolve in hot water. So what happens? Little fishies suffocate.
So you said gases decrease solubility as
Temperature increases, that's right. They're different than ionic compounds, right? Most ionic compounds increase solubility, but gases decrease solubility. Okay?